Okay, adding and subtracting vectors. First, yeah, you must know standard position for vectors. This is big one. So now we're going to do operation on vectors. Operation on vectors. What we mean by operation on vectors? Adding and subtracting. Adding and subtracting. Multiplication by a number, it is easy. You don't have any problem with that. Okay, so we go here and we're going to do an example. So right here, example. I'm going to add some vectors. Example, find the resultant, the resultant vector of V1. I'm going to put it as a force, or V1. It can be any vector. V1 equal 30 degrees north. V2 equal 30 degrees, 30 newtons, 30 meters per second. I'm going to put it 30, and I'm going to put 45 south, 20 degrees west. Okay. So what I am looking for, it is adding the vectors. So what I want to find, it is the VR, the total. I'm going to put it total, but we can put it as a resultant. The total equal V1 plus V2. This is what I want. I want to add these two vectors. They are vectors. I can't add the 30 to 45. No, because these ones are magnitudes, and I can't add the directions. There is some ways how to. This is total. Vector total equal V1 plus V2. So we have some steps. We have some steps. Step 1. So I'm going to put it here. Step 1. Find the standard position for the vectors. The standard position for the vectors V1 and V2. We have to find standard position for both of the vectors. We did how we found standard position. V1, it is 30 north. So what will be the standard position of this vector here? You can draw it. This is what we did. This one, it is east. This one, it is north. This one, it is west. This one, it is south. And we said this one, it is 0 degrees. This one, 90 degrees, 180 degrees, 270 degrees, and 360 degrees here. Remember? So what is the vector here? It is on north. So we're going to put it on north. 30 degrees north. It is here. This is my vector. I'm going to put it in blue that it can appear. This is my vector. It is in the north direction. And this is 30 meters per second because they are velocities. So what will be its standard position? Standard position goes always from the east to the vector. So it will be 90 degrees. Are you okay or not? And you are here 90 degrees here. So we have to find the standard position for the other vector. The other vector, it is what? 45 meters per second because this is velocity. And we have south 20 degrees west. And this is what we have here. Okay? And this is what we have here. So what we have? We have east, north, west, south. This one, it is 0 degrees, 90 degrees, 180 degrees, 270, 360. So what is the vector southwest? It must be here between the south and the west. You know all that stuff, huh? So I'm doing it only for to make the video a little bit more independent. That's it. And southwest, it will be this angle here. My angle touches the south because it started by the south. This is 20 degrees. So what will be my theta, or the direction, or the orientation, or the standard position? It is from the east until the vector. This is the theta here, the angle. So how are we going to find this one? Found it to me. So it will be what? So find it. 270 minus 20 degrees. It will be 250 degrees. Why minus? Because my angle, it is between 180 and 270. It is not bigger than 270. So I have to minus. So this one, this vector here, it is what? 45 meters per second. And the direction, the standard direction, it is 250 degrees. Since this is the first step, you understand? Now the second step. Step 2. We are going to build a table. Step 2. We are going to build a table like that and like that. Here I'm going to write vectors. I'm going to write V1, but this time I'm going to write V1 with the standard position. What is V1? It is 30 meters per second, 90 degrees. So it is here. It is what? 30 meters per second, 90 degrees. And I'm going to write here V2 equal 45 meters per second. And what is the direction? You have it in your notes. 250? 250 degrees. I have these two vectors here. I'm going to underline here. And I'm going to put a plus because I want to plus them. So here what you have to write, you have to write horizontal component. Horizontal. You can put it X. We call it X because horizontal always X. Vertical. And we're going to put it Y. Y, it is always vertical. Okay. And look what we do here. We have a formula now. What I'm going to put here? I have to put the 30 times cosine 90 degrees. This one, what I have to put here? 30, because I am always in the line of 30, times sine 90 degrees. So the horizontal, it is always with cosine. I'm going to put it here. And the y, it is always with sine. For this, the other one here, I'm going to put 45 cosine 250. And I have to put here 45 sine. I'm going to put it a little bit lower because I want to. This one here, it is 45 cosine 250. And here 45 sine 250. So take your calculator and give me what I will find in each value. 30 cosine 90, what I will find? I'm going to put in another color. Zero. I put it here. This one gives you 0. What about the sine? 30 sine 90 degrees. Let's give me what? 30 meters per second. What about this one? 45 cosine 250. Negative 15. 15 dot what? 15.4. And what other digit? So it was 39. You rounded it. Okay, here 45 sine 250. It will give you what? 0.283. Good. So do you understand what we did? We find the first step. It is finding the standard positions, and we have to add them because this is what they asked us. So add them. I'm going to write it here, V total, because this is what I want. And add them here. 0 minus plus minus. So I'm going to put a plus here and a plus here because this is what I want. I have to add the components. We call it the components of the vector. So this one will be minus 15.4 meter per second. Here it is, meter per second. Which one? This one here? Excuse me? Huh? You wrote 6. 4. It is 4 instead of 6. Yeah. All right. And this one, you add them, it gives you what? Minus 12.3 meter per second. You are okay? So, step 3. Did you understand what we did here? Step 3. What we found here, we found the vector total. I'm going to write it here, V total. And we are going to put them on brackets here. Why I'm going to put them on brackets? Because I have an X and a Y. Minus 15.4 and I have minus 12.3 meter per second if you want. I'm going to put here, but here to not. Now, step 3. Yeah, we did them here. Step 3. Right, step 3. In the step 3, what we have to find the magnitude and look what we are going to do. I find the V total. I'm going to put it again on brackets. What we found what are the components of the V total? It was minus 15.4 and it was what? Minus 12.3. Now I have to put them in the Cartesian plan here. Okay? This is X and this is Y. And this is also East. This one, it is North, West, South. You understand? So I have minus 14.4. So it is somewhere here because it is negative. In the X, it is here. This one, I'm going to write it minus 15.4. And I have the Y negative minus 12.3. It is here. So where is my point? I have to put it here. This is my coordinates here. Excuse me? Yeah, you have to find this point here. The point with the coordinates minus 15.4 and minus 2. And now our vector now, it is here. It is from the center to the point that we put. This is the vector that we are looking for. Okay? Now I'm going to work with the triangle. Which triangle we are going to work? We work always with the triangle that we have with the horizontal. We're going to work with this triangle here. And this triangle has a property. It is a right angle. Right angle here. And I have sides. What is this side here? Where I put this, I'm going to take it from here. The 15, it is here. On the top. Minus 15.4. So this side, it is 15.4. And this side, what is this side here? In your opinion? 12.3. Yeah, the Pythagoras theorem. So put it to Pythagoras theorem. I'm going to C squared equal E squared plus B squared because we are looking for this C here. Pythagoras theorem. So do it. C squared equal 15.4 squared plus 12.3 squared. We ignore the minuses. Okay, because sides are positive in Pythagoras. We don't put the minuses. I see that you put the minuses. Don't put the minuses. Or if you want to put the minuses, put the brackets. But you have to put them on brackets. Okay, no. Okay, this one. If you want, but you don't have to put the minuses if you want. So C squared, so find C. So what you are going to have, you will have C equals square root of f the 10. So C it will be, so I'm going to calculate it. This is Pythagoras theorem, 15.4 squared. You put for 15.79, it is 8. So we find that the vector here. So we're going to write the magnitude of the vector. This is the C. The C here, it is 15.8. Okay. And we are going to write, so V equal, V total equal 15.8 meter per second. And we have to find the direction. The direction, it is this angle here, theta. The theta, it is this one here. We have to find this theta here. The angle between the west and the vector. Okay. And we have to find this one. Good. So how we are going to find the theta? We are going to start to find cosine, sine, or tangent. We are going to use tangent. Always in here, we are going to use tangent. We are going to always tangent. Tangent theta equal opposite adjacent. So what will be tangent theta? What is the opposite? 12.3. What is the adjacent? Positive. Positive. Take always only the positives. 15.4. And the theta here, give me the theta, what will be the theta? I'm going to find also the same what you are doing. 12.3 divided by 15.4. Excuse me? You find the angle? Okay. Tangent response. Excuse me? I don't know what I did in my calculator. I think I did it wrong. 12.3 divided by 15.4 equal tangent this one here 38.6 or 39. So this angle here, it is 39 degrees. And now we have to give our vector 39 degrees. So what will be our vector here? My angle touches the west until this. So I'm going to write it west because the theta touches the west. 39 what? South. So this is my answer. Okay. So here I'm going to give, fourth step, it is answer. For step 4, V1 plus V2 equal V total. And V total is 15.8 meter per second west, 39 degrees south. You understand what we did? We are going to do another. Do you need another example or you are okay? Excuse me? You wish okay, you know how to do them? So I'm going to stop here, but I'm going to give you exercises. I want you to do them before leaving. Again. So, going to this one's here. So, here, exercise. So, first, find V total equal 30 newtons. This is Newton, not north. West plus 45 newtons south. 2. V total, we are the force total. This one, I'm going to put the force. It's not a V, but a force because newtons are force. So I'm going to force total here. Displacement, total displacement equal 45 north, 30 degrees west, east, minus 30 this one meters east, 45 north, and third one, this is velocities. I'm going to add 25 south meter per second south plus 45 south dot 30 degrees east minus 54 meter per second. I'm going to put here west 20 degrees south. Yeah, you have to do plus and minus and in your table. That's it. Here you are going to have 3 lines.
Oh yeah, because the triangle is
Yeah.
basically just put the
No. You have to follow the steps that we did. The steps is here. I have 2 vectors here. I'm going to have a third. For example, V3. And here it was a minus. I'm going to put minus. And the N I will have always the same. Follow the steps. V1, V2. I can have V4. I can have many vectors that I want. Okay, you understand? So do these exercises here. And you come back to me. Okay, bye. Goodbye.